Our today's topic is vector product or cross product. Here we discuss about vector product or cross product of the two vectors. Consider the two vectors A and B are inclined at an angle theta. Then it gives a third vector C. That vector is perpendicular to the plane containing the vector A and B. Then what is the magnitude of the vector C? The magnitude of the cross product of the two vector or vector C is equal to the product of magnitude of the two vector and sine of small angle between them, and it is represented as vector product or the cross product of the two vector is equal to AB sine theta. That cross product we explain with the help of right-handed screw rule or right hand rule. Now what is right hand rule? The curled finger gives the rotation of the vector A to vector B through the small angle theta, and the outstretched thumb indicate the direction of the vector product. Here right hand rule is equivalent to right-handed screw rule. Both are equivalent. Now what is the right-handed screw rule? If the screw is rotated from vector rotated in the direction from the vector A to vector B through the small angle, then the direction in which the tip of the screw moves indicate the direction of the vector product, and that product is same. A cross B is equal to AB sine theta. It means, it shows here the vector product of the two vector is a vector. Now what are these example? The first example we see angular momentum L. Angular momentum is a vector quantity. That angular momentum is the cross product of position vector and linear momentum vector, and therefore it is the product of R cross P. R is a position vector, P momentum vector. The cross product of two vector is again vector, and that vector is angular momentum vector. Second example, the relation between angular velocity and linear velocity. That relation also gives a vector term, means vector V is equal to vector R cross omega. R is position vector. What is omega? Angular velocity. Hence the relation between angular velocity and linear velocity gives vector term, vector linear velocity. That vector is equal to the cross product of the two vector, vector R cross omega. Third vector, if the torque is acting on a magnet whose magnetic moment is M and it is kept in magnetic field of induction B. Then this torque tau is a cross product of M multiplied by M cross B. M is the magnetic moment. B is the magnetic field induction. Here the cross product of the two is again a one vector, that is the torque tau. Then we discuss about its characteristics. The characteristics of the vector product or the cross product. The first characteristic we see earlier, the cross product of two vector is a vector. It is a vector quantity. Example we see angular momentum, relation between linear velocity, angular velocity, and the torque tau when it acts on a magnet, which magnetic moment M, and that magnet which is kept in a magnetic field induction B. Then it also represents a cross product of the two vector and it gives a vector. Second characteristic is that it does not obey commutative law. It means if we interchange the order of the two vector, then the two terms are not same. Means vector A cross vector B. And if we interchange the two vector, if we initially write the B cross A, then the cross product of these two terms is not same. These gets to be reverses its sign. And hence we write vector A cross B is equal to minus of B cross A. Here is minus sign, therefore it does not obey commutative law. Third characteristic is vector product is distributive over the vector addition. Now, how that characteristics we explain here. Here we take the cross product of vector A and B plus C. Then it obey product is distributive over the vector addition. Simplify the bracket, vector A cross vector B plus vector A cross vector C. Next, we write the vector A and B are parallel. If both vectors are parallel, angle between them is 0. Or if they are anti-parallel, sin theta equal to 180 degree. Then what is the result? Vector A cross B is equal to AB sin theta. This term you know. If theta is 0, sin 0. If theta is 180 degree, again sin term is 0. Therefore, vector A cross vector B becomes equal to 0. So this is the one of the characteristic here. Next characteristic is that the vector product of a vector with itself is a 0 vector. It means we write the vector A cross vector A. What is the result you get? A into sin 0. Since both vectors are in the same direction, just say there is no angle between them. Sin is 0. Again A cross B is to be 0. And therefore we say the vector product of a vector with itself is a 0 vector. If both vectors are perpendicular, vector A and B are perpendicular to each other, then what is its cross product? That cross product is to be AB, its magnitude only. Now, if both vectors are perpendicular, what is angle theta? Theta is 90 degree. And what is sine 90? 1. Therefore, vector A cross B equal to 90 degree. Vector A cross B is equal to AB sine 90. Therefore, simply we get AB. Now we see what is the cross product of the two unit vectors. See, here we say the A cross B is AB. That explanation we write here. Theta is 90 degree. Sine 90 is 1. Therefore, vector A cross vector B equal to AB. Now we see what is the vector product of the two unit vectors. It means if we write I, J, K, these are the three unit vectors along X, Y and Z axis, and we take their cross product. Suppose for example we write vector I cross vector J, then what is the term you get? I cross J. Both are unit vector, therefore magnitude is 1. But what is the sine 90? These are mutually perpendicular, therefore sine 90 is 1. Therefore we get 1. But the cross product of two vector, if we just according to the definition, we say that I cross J, this is in the one plane, is correct, and it gives its result, third vector is along the Z direction, and in that Z direction, this is a perpendicular vector to the plane containing the vector I and J. Therefore, the result is I cross J is vector K, or vector I cross I, it is according to that rule, it is 0. Here that rule. Therefore, we write vector I cross I is equal to J cross J equal to K cross K equal to 0. Since both vectors are in the same direction, theta is 0, sine 0 is 0. Therefore, I cross I 0, J cross J 0, K cross K 0. And other case, I cross J that equal to vector K. Since I cross J, I and J are the two vectors inclined at an angle, small sine angle. I, J, K are mutually perpendicular to each other. Therefore, the result is I cross J, and that result is along Z direction. Therefore, along that Z direction, what is the unit vector? Unit magnitude, vector K. Similarly, J cross K, that is equal to I. Next, the K cross I, that equal to vector J. This is the cyclic order. If we multiply I, J, K in the clockwise direction, we get the positive result. And if we multiply in the opposite direction, anti-clockwise direction, results are negative. For example, I cross J, we get plus K. J cross K, we get plus I. Or if we reverse the direction, it means J cross I. This is the anti-clockwise direction. J cross I. What is the result you get? Minus K. I cross K. I cross K minus J. K cross J. We get minus I. And that term gives the characteristics of vector product or cross product. Now we see the next term, cross product of two vector. If we know, then what it is? Component. That component we discuss here. To find the cross product of two vectors in terms of components. For that, we choose two vectors. Vector A is taken as vector I AX plus vector J AY plus vector K AZ. I, J, K, these are the unit vectors along X, Y, Z. And what are the components along that component of the vector A along x, y, z? Ax, Ay, Az. Similarly, other vector B. Vector B is also written in terms of the unit vector ijk, vector I dx plus vector j dy plus vector k bz. Bx, by, bz, these are the components of the vector B along x, y and z axis. Now we take the cross product of the two vectors. Hence, we write the next step, vector A cross B is equal to Ix plus Jay plus Kaz, cross product of vector B. Vector B is Ibx plus Jby plus Kbz. Now simplify the two brackets. How we simplify? Ix multiplied by second bracket, Jay multiplied by second bracket, this bracket, Kaz multiplied by this Ibx plus Jby plus Kbz. Therefore, this is we write directly here. Vector Ax cross bracket is same. Similarly, plus Jay cross bracket same. Hence, we write the three terms separately. Again, we simplify each and every term. Here, how we simplify this term? Vector Iax cross vector Ibx. Now here, I cross I. What is I cross I? 0. Therefore, this terms becomes 0. Second term, Iax cross J dy. What is I cross J? K. Therefore, we write Kax dy. Therefore, we write here vector Kax by. This is the first term we write. Next, we write Ix cross Kbz. What is I cross K? I cross K. This is minus J. Therefore, we write the minus J Ax Bz. Now, this is the expansion of the first term, and we get the two terms here. One term is 0, I cross I into Ax Bx. Therefore, I cross I is 0. Therefore, this term is 0. Remaining two terms we write here. Similarly, second term we simplify. Jay cross Ibx. J cross I. This is in the anti-clockwise direction. J cross I. That direction we just writing here. Here, just say J cross J 0. J cross K. J cross K I. Therefore, it is to be minus K Aybx plus I Aybz. This is the result of the second term. Now simplify the third term. Kaz cross Ibx. K cross I. K cross I plus J. Therefore, write vector J Az Bx minus K Az cross J By. Therefore, K cross J minus I into Az By. That's it. Third term, K Az cross K Pz. K cross K 0. Therefore, that term is 0. In the first two terms is result of the first term minus K Aybz Bx plus I Aybz. This is the result of the second term. These two terms, and last two terms is the result of the third term. Now we simplify this term. We combine I terms, J terms and K terms. Therefore, vector A cross vector B is equal to vector I. Here are the two terms, first and this plus I ay bz and minus I az dy. Hence we combine together, take common I. Similarly, z terms we combine. J into positive term we write firstly az bx minus term ax bz plus k term, take common, and here both terms we combine together, k terms, k is common, ax by minus ay bx. Now vector a cross vector b we get in terms of vector I j k, means the bracketed terms are the components of the a cross b. This is the, we write here the ay bz minus az by, that is the component along the unit vector I. Az bx minus ax bz, that component is along unit vector j. Here ax by minus ay bx, that component is along unit vector k. Now therefore the cross product of the two vectors we write in terms of the determinant. Vector a cross b is equal to this unit vector we write firstly, and the component of the vector a we write ax ay az. Now this is the second row, first row ijk, second row ax ay az, third row about the vector b, bx by bz. Therefore we get the 3 column and 3 rows. That determinant if we solve, we get the same. Hence the cross product of two vectors we express in terms of their components. That components are vector a cross b in terms of I, j, k, or in terms of the determinant. Here we complete that term, cross product or vector product of the two vectors. We explain the next term in the next lecture. Thank you.